Right, question 3. Show that the root lies between 0.4 and 0.5. So what I do here is I always let the function equal the initial graph, and then I take off the other graph, which in effect what you do when you're finding points of intersection. And then I put in f of 0.4 into that equation and f of 0.5 as well. 0.4 then giving you 0.3 and 0.5 giving you minus 0.1. So then you can just put change of sign. So that then implies that the root, which we're talking there, is alpha. So alpha then has to be between 0.4 and 0.5. Part B, show that the equation can be written in this form. So we've got cos to the minus 1, 2x minus 1 equals e to the x. Well, that's the inverse of cos. If you cos both sides, that will then leave with 2x minus 1 equals cos e to the x. Then we're going to add 1 to both sides, so 2x then equals cos e to the x plus 1. Then we divide both sides by 2. And then if we times the half into this, then we get a half plus a half cos e to the x. And there's one mark for all that. Part C is an iteration question. So it wants x1 that, and it wants to find x2 and x3. So x1 you're given is 0.4. x2 I'll write out fully how you do that. You sub in x equals 0.4 into your equation. And then that will give you, and what's it wanting it to? 3 decimal places, so 0.539. And then x3 is the same, but this time instead of putting 0.4 in, we'll put in 0.539. Now you must put in the whole value. Alright, don't round it. You round it here, but you keep that in your memory. And then doing so gives you 0.428.